Hi guys, welcome to my physics class. This time we're gonna talk about final velocity after any displacement. These exercises, you'll find them from page 53, 54. 52 and 53. Okay, let's see. First problem. A person pushing a stroller starts from rest. As we already defined, when a word problem in physics says starts from rest, means that initially the object was not moving. If it's not moving, then we say that the initial velocity is 0. So this is how we get the first given. Initial velocity 0 meters per second. Then it says uniformly accelerating to a rate of 0.5 meters per second square. That means that the accelerating at this rate. So acceleration equals 0.5 meters per second square. What is the velocity of the stroller after it has traveled 4.75 meters? So this is very important because it says velocity after. When we talk about a velocity after, that means that we're talking about a final condition, so we need to find the final velocity. This is the unknown. But also it's giving me another important given, which is 4.75 meters. That is displacement. So we say x equals 4.75 meters. Now let's take a look. The equation that we use for this topic is already here. Final velocity is equal to the square root of initial velocity squared plus 2ax. The main equation is the first one that you see over here, but this one is already isolated for the final velocity. Now what we have to do is just plug in the givens. There you go. Initial velocity is 0 plus, from the formula, 2 acceleration, which is 0.5 meters per second square, and distance or displacement in this case, which is 4.75 meters. Now the next part is something that you have to use your calculator. Let's see. I'm gonna place it over here because I didn't see anything from in this side. Okay, let's see. So how are we going to solve this? First of all, we're going to solve what is inside the square root. That is 0 to the second power is going to give you 0. So we basically don't need to do this part. This is what we know is cancel. But anyway, you can use it if you want. Plus, okay, 0 to the second power plus 2 times 0.5 times 4.75. So we have the square root of 4.75. Now, what units are we going to place inside our square root? Meters times meter is going to give you meters square. And below, we're going to keep having the seconds square. After this, what we have to do is just get the square root of the answer. And there you go. 2.18. Okay, here, what do we do? The square root cancels the exponent, because this is a square root and this is a square exponent, so they're both cancelled. Now we have meters per second. Now, what symbol is it going to be? Positive or negative? As you can see, initially the stroller was at rest. After it was accelerating, it traveled 4.75 meters. Is it positive or negative? Okay, it was at rest and then it moved. So we say that when acceleration causes positive acceleration, because this is positive, causes positive velocities. So in this case, we're going to have positive velocity, final velocity of 2.18 meters per second. This is going to be our final answer. Now let's see the problem number 2. An electron is accelerated uniformly from rest in an accelerator at 4.5 times 10 to the 7th power meters per second squared over a distance of 95 kilometers. Assuming constant acceleration, what is the final velocity of the electrons? So now we're talking about electrons in physics. Yeah. I mean, electrons can have physics behavior if you want. So both classes, yes, are related somehow. Now take a look. We're going to take the givens first. It says accelerated uniformly from rest. When it says from rest, the word from talks about an initial condition. So when it says from rest, we know we have the first given as initial velocity 0 meters per second. Now it says accelerates uniformly at this acceleration. So how do I know this is an acceleration? The exponent here, meters per second squared, tells me this is an acceleration value. So this is my second given, 4.5 times 10 to the 7th power meters per second squared. After that, it says over a distance of 95 kilometers. As I told you before, displacement or distance can be should be written in meters. So this kilometer should be transformed into meters by doing what? A simple conversion. So 95 kilometers times the conversion factor between kilometers and meters is, in 1 kilometer you have 1,000 meters, and this will give you a final answer of 95,000 meters. So this is the other given. This is x equals 95,000 meters. Now, assuming constant acceleration, what is the final velocity of the electron? My unknown is final velocity. This is what I'm looking for. So as I'm looking for a final velocity, let's use the equation that we already have for this type of problems. This is the equation for final velocity. Now let's going to plug in the givens here. Let's make sure that we have everything. We have initial velocity, the 2 is over there, is a constant. We have acceleration and we have displacement. We have everything that we need to solve the problems. So now just let's plug in the values. Here is 0, initial velocity is 0. And 95,000 meters. There you go. This first term, as it is 0 raised to any power, is going to give you 0, so you can just ignore it. And we solve for the rest of the equation. 2 times. Now take a look. How do we write the scientific notation? 4.5 exp. And now the 7. We don't take in consideration the 10. Okay, just exp 7 times 95,000. Now we have the square root of this number over here, 8.55 times 10. Take a look, it says times 10 to the 12th power. I don't know if you are able to see because of the light. It says times 10 to the 12th power. Now what units? Meters times meters give you, this is like having, I'm gonna do this apart. This is like having meters per second square times meters. Meters and meters is going to give you meters square over second square. This is the unit that you will have inside the square root. meters square over seconds square. Now, when you take the square root, how you do it in the calculator? Square root of your answer. Now take a look. This gave me 2.92. Okay, I will write this in scientific notation. Times 10 to the 6th power. Now, what unit is this? Meters over second. Why? Positive and negative. Why? Now, is it positive? Is it negative? It's positive because the acceleration is positive. So, positive acceleration produces positive velocities as we have here. Now, why did I get meters over second if I had before meters square over second square? Remember, you are getting the square root of a number, but also square root of units. So you're gonna have this, and what happens over there? You cancel. This is like having square root of m to the second over square root of seconds to the second power. So take a look. This and this is cancelled. This and that is cancelled. What is your final unit? Meters over second that we had over there. Now this last problem, as you can see, it's in grade B and C, because B and C will be your homework this time. Now in this sample problem 3, we have a car traveling initially at 7 meters per second. Then what happens? That car accelerates uniformly at a rate of positive 0.8 meters per second square. For how long? Not for how long. How many meters, or what distance that car traveled? At a distance of 245 meters. Question: what is the velocity at the end of the acceleration? As you can see here in this type of problems, we are not considering the time. That is a key for solving these problems, because this equation is not considering the time. It's just considering the displacement that the object had during the problem, or during all these conditions. Now let's see. Traveling initially at 7 meters per second is giving me an initial condition in meters over second. We say that is velocity. So we have the first given, initial velocity, positive 7 meters per second. Then it says accelerates uniformly at 0.8 positive. So we have a positive acceleration of 0.8 meters per second square. And now it's giving me a distance of 245 meters. So we have x equals 245 meters. Unknown. Question is velocity at the end of the acceleration. Velocity at the end just tells me or asks me about a final velocity. Now take a look. This is the equation that we're going to use, of course, because we're looking for a final velocity. Now let's just plug in the values. Initial velocity 7 meters over second to acceleration 0.8 meters per second square, and displacement 245 meters. Now this type of problem where we don't have the first velocity is 0, we're going to consider we need to raise this number to the second power, 7 to the second power. So we're going to have 7 to the second power is 49 meters over second to the second power is, take a look, meters over second to the second power, it is having this meters over second, both of them square. So we're going to have meters square over second square plus this isn't that 2 times 0.8 times 245. This gave me 392 meters times meters square over second square. 392 plus 49. This gave me a total answer of 441 meters square over second square. Now I'm just gonna get the answer, the square root of my answer, that is 21, exactly 21. Now the square root of meter square over second square is just meters per second, as I told you before. Positive or negative? Acceleration positive, velocity will be positive. Remember, positive accelerations produces positive velocities. So this is it, guys. Practice this topic, do B and C, and see you later. Well, we'll talk about it later. Bye bye.